Welcome to clickmyproject.com. Now we are going to discuss about the product semi-automatic detection and segmentation algorithm of saccular aneurysms in 2D cerebral DSA images. Now we are going to discuss about the abstract for the process. Detection of optic disc area is complex because it is located in the area that is considered as an pathological blood vessels when in segmentation, and thus requires a method to detect the area of the optic disc. This paper proposed the optic disc segmentation using a method that has not been used before, and this method is very simple. K-means clustering is the proposed method. In this paper, we proposed the optic disc segmentation by using the K-means segmentation only. After this clustering, the cup region and the optic disc region is segregated separately. Then the segregated results is combined together and then indicated by the contour deduction. If the distance between the cup and the disc region is more, means the iris region is affected. Otherwise, if the distance between the cup and the optic disc is low, means the disease is not affected. This paper successfully detected the optic disc area quickly and segmented the blood vessels more quickly. Now we are going to discuss about the flow diagram for the process. This is the overall flow structure for the process. At first, the input image is taken from the dataset. The dataset is the folder which consists of the several input images. After getting the input image from the dataset, the segmentation is carried out. In this segmentation process, we use the modified FCM is used to cluster the optic and the disc region. This is abbreviated as an MFCM. Then after the segmentation, the disc ratio calculation is carried out. In this disc ratio calculations, the disc region is calculated as a blob 1 and the cup region is calculated as a blob 2. Then the finding the distance ratio between the optic disc and the cup region is calculated by the distance calculation. If the ratio is less, means the disease is affected, or otherwise it will not be affected. So hence, after the detection of the disc and the cup ratio, the performance is estimation. In this performance estimation, we have the 5 types of performance is estimated. First one is the accuracy, then the second one is the sensitivity, then the third one is the specificity, then the fourth one is the PPV, that is the positive predictive value, then the fifth one is the correlation. Hence, by using these 5 parameters, we can justify our process is efficient or not. Hence, the segmentation is more reliable to improve the performance of the process. Now we are going to discuss about the initial running procedure for the process. At first, open the MATLAB 2013 and change the current directory. If you want to execute the code, means just right click in the main_boundary.m file and select the option run. Now the initial GUI design was opened. In that you can see the several push buttons in the left side to control the axis and the axis to display the images. At first, click the button input image. After clicking the button input image, you can see the folder datasets. Now open the folder dataset and select any one image from the folder datasets. After the selection of the input, the selected input image is shown in the axis 1 with the title input image. Now click the button active contour method. After clicking the button active contour method, the contour is applied to the input image, and then the contour segmentation is applied to segment the retinal regions. hence the active contour is applied by the iterations. Here the green color boundaries represents the active contour, hence it is done in the grayscale image. The active contour method is taking some more time to the executions. After applying the active contour, then the region growing is carried out. In this region growing method, the initial disk region and the cup region is masked and then shown in the figure 2 and the figure 3. Now the modified FCM is applied. After applying the modified FCM technique, the clustering is done for the retinal regions. After applying the clusterings, we have to choose the image. Now the cluster 1 shows the appropriate results. Now click the button 1 and give enter. Now the selected cluster is shown in the axis 1 with the title objects in clusters. Now click the button boundary detection. In this boundary detection, load the input image, then extract boundary. In the extract boundaries, the outer regions will be displayed, then disease predictions will be displayed. Here the area 1 and the area 2 is calculated and then displayed. Here the disease is not affected. Then click the button estimations. After clicking the button estimation, it will take some time and then the estimations will be carried out. Now the accuracy, error rate, sensitivity, specificity is shown in the command window.
Thanks for watching this video.